Open up your MTT. We're going to work with scientific notation today. We're going to do a quick review on how to write standard form and scientific notation form of numbers. So if we're given the scientific notation, we're going to look at the exponent. If the exponent is positive, that means our number is going to get larger and the decimal is going to move to the right. So the first thing that you need to do is find your decimal. So the decimal on the 4 is going to be behind the 4. The 3 tells us that you're going to move the decimal 3 places to the right. So that's going to give us 4,000 for our standard notation. The next one, we're looking at the decimal, and our exponent is positive. So we're going to move that decimal 5 places to the right. 1, 2, 3, 4, 5. So it's going to be 3, 2, and then 4 zeros. All right, now the next one, we have a negative exponent, which means our number is going to get smaller, and the decimal is going to move to the left. So again, you put your decimal in so you can see where you're starting, and we're going to go 4 places to the left. So we're going to go 1, 2, 3, 4. So we're going to add in our 3 zeros and put our decimal in front of all of them. Okay, let's make that decimal a little bit better. Okay, the next one, find your decimal. Now we're going to move 7 places to the left. So we're going to go 1, 2, 3, 4, 5, 6, 7. Fill in with zeros. That's going to give us 6 zeros and a decimal in the front. All right, now what do we do when we are looking for a standard number and we need to put it into scientific notation? Well, we need to remember that the format for scientific notation, the first number is going to be between 1 and 999. Then you're going to have a times, and then you're going to have 10, and then you're going to need to figure out your exponent. So we're going to go ahead and put the decimal in with our magic pencil, and it's going to go in between the 4 and the 1. So it's going to be 4.1 times, and now we're going to move the decimal so that we get back to the number that we started with. So we need to move to the right, 1, 2, 3, 4, 5, 6, 7. So it's going to be 10 to the 7th. Okay, the next one, we're going to put our decimal. Again, the number has to be between 1 and 999, which means our magic pencil is going to put that decimal between the 6 and the 5. So it's going to be 6.51. Don't drop off any of the digits unless they are zeros. Times, and now we're going to move 1, 2, 3, 4 places to the right. Now this time our number is small. So again, it's too small for the number in our scientific notation. So we're going to need to move that decimal. So we're going to put it between the 1 and the 9. 1.9 times. Now we need to move the decimal back to where it started. So it would be 1, 2. So it's going to be 10 to the negative 2. Again, our number is too small, so we need to put the decimal after the 7. So it's going to be 7.0. Make sure you add that 0 for place value. And now we're going to move it back to get to where it was started. So 1, 2, 3, 4, 5, 6. So we went back 10 to the negative 6. Now we're going to work with multiplying in scientific notation form. When you multiply in scientific notation form, you're going to multiply like parts. So you're going to notice that we took the whole numbers, or rather the decimal numbers or whole numbers, and put them all into one parentheses. And then we put all of the base 10s into the second parentheses. And now we're going to just simplify the parentheses. So 3.1 times 2 is 6.2 times, and our bases are 10, they match, so all we're going to do is add the exponents. So it's going to be times 10, and then 7 plus negative 5 is going to give us 2. So our answer in scientific notation would be 6 and 2/10 times 10 to the second power. In standard form, we're going to take that 6.2 and we're going to move the decimal 2 places to the right. So in standard form, we're going to have 620. So this is standard and this is scientific notation. Let's do another one. All right, so remember, we're going to collect up the whole numbers or decimals and put them into the first parentheses. This is going to be 1.4. And then we're going to put all of the base 10 numbers into the second parentheses. So this is going to be 10 to the negative 4. Now we're going to go ahead and multiply. 1.4 times 5, as you can see over here, is 7. So we're going to have 7.0 times 10 to the, now we have negative 2 plus negative 4. So negative 2 plus negative 4 gives us negative 6, which is our new exponent. That's how you would write the number in scientific notation. Now, in standard form, of course, we're going to take the 0.7, 7 with the decimal behind it, and we're going to move it 6 places to the left. So it's going to be 1, 2, 3, 4, 5, 6, which is going to give us 5 zeros in front of that 7 with the decimal, and this would be standard form. Now, let's do another one. In this case, we're going to, again, collect up the whole numbers or decimals and put them into one parentheses. Collect our base tens and put those into the second parentheses. 4.2 times 3 is 12.6 times, and we have 3 plus negative 1, so it's going to be 10 to the second power. Now, the only problem with this is that our first number right here is not between 1 and 999. So we're going to need to take this number and rewrite it in scientific notation. So over here on the side, we're going to take 12.6, and using our magic pencil, we're going to put the decimal where it has to be, which is between the 1 and the 2. So this is going to be 1.26, and now times, and now we're going to take it back to where it was. So we're going to move it back 1, which is going to be 10 to the negative 1. All right. Okay, now remember that we moved to the right, so it's not negative 1. It's actually going to be positive 1. All right, so we took 12.6, brought it over here, and we have to rewrite it into correct scientific notation. So we put in the decimal where we wanted it, which is between the 1 and the 2, and then we have to move it back to where it was for the original number. So that goes back there, so we went one place to the right. So now we're going to come over here and we're going to substitute in 1.26 times 10 to the first times 10 to the second. So here is 12.6 written in scientific notation, and then we just drop down our 10 squared. So now we need to simplify again. So this is going to be 1.26 times 10 to the third, because we have 1 plus 2. Base 10s are the same, so we add our exponents. So our answer is going to be 1.26 times 10 cubed. Now we can do the same thing with division. What we're going to do first is we're going to take the 5.1 and divide it by the 1.5, and you'll see that I did that over here, and that's going to give us 3.4 on the top, because our larger number was on the top, and now we have times 10 to the 6 and 10 to the second. Now all we're going to do is ask ourselves, where do we have more tens? Well, we have more tens on the top, and so how many more do we have? We have 4. So our answer is going to be 3.4 times 10 to the fourth. All right, let's try another one. Now this one, we have a problem because we have some negative exponents, and we cannot simplify until all of our exponents are positively happy. So we're going to go ahead and rewrite this. 7.2 times and 4 times. Now, because this is a negative, we need to put him down in the denominator to make him positively happy. And because this is a negative, we need to put him up in the numerator to make him positively happy. Now we can start looking at the pieces. So we're going to take 7.2 and divide it by 4, which I did over here on the side. And you'll notice that we get 1.8 on the top times 10 cubed and 10 to the fifth. So now we ask, where do we have more tens? We have them on the bottom. How many more do we have? We have 2. So this is 1.8 over 10 squared. Now this would be our answer, except that we have to have it in scientific notation. So that means the 10 has to be up in the numerator. So right now the exponent on the 2 is positively happy. When we move him up to the numerator, he's going to become negative. So it's going to be 1.8 times 10 to the negative 2. If we were putting this into scientific notation, we would be done. If we need to put it into standard form, then we would take the 1.8 and we'd move the decimal to the left, 1, 2, so that's going to be 0.018. And let's go back and do that on this one too. What would this one be? This is scientific notation, and in standard form it would be 3.4, and we'd move it 4 places to the right, 1, 2, 3, 4, so it would be 34000 with a comma. And that's how you do scientific notation.